So thanks a lot. I'm really excited to be here sharing something about what we learned in terms of bamboo construction. So I really want to say thank you to the Taiwan Bamboo Society, to Professor Pei, to Lin as well, to invite us to come here and run a 5 days course here in in Taiwan, to come from Bali to here and then try to share with you a little bit about bamboo construction. So at Bamboo Yurt, we like to explore architecture as a space where education, design, and nature can converge. So for more than 10 years already, we have learned directly from the living intelligence of nature, from the living intelligence of bamboo. And our mission is not only to teach how to build with this material, but also how to think through it. So it's just like a matter of way of thinking when we work with bamboo, because in every workshop, in every drawing, in every prototype, it's a small experiment in what it means to build with nature, and really not against to it. So on that journey in Bamboo Yurt, we have learned that to really truly understand how to work with bamboo, we must first understand its structure and its logic, its anatomy and its lightness. So that's what I want to share with you today. And before we dive into that, I would like also just give you a little bit of context and why I'm here now. So I was born in Mexico City and studied architecture and structural engineer in Mexico. And I run my own company in terms of design and construction in a beach town that is called Puerto Vallarta. And as an architect, and I guess as a human being, I've been always inspired and asking myself this question, what if? And that question had been like the common thread through most of the projects. So the first projects that I was involved, it was all about medical facilities and hospitals. So the idea was, in this project is a medical facility for a dermatological clinic. So the idea was like, what if we can just show the materials as the skin of the project? So that metaphor of the skin, because of the clinic, was dermatologic, and then show in its materials like exposed concrete and a very small material palette, the materiality of the project. And in Puerto Vallarta, as a beautiful beach town, it's nice, but as well we have natural disasters. So we've been asked to design and build an ER clinic as fast as possible, and design and construction at the same time in just about 6 months, and being able to produce its own power. So once we are building hospitals and medical facilities, we face a lot of challenges, and one of those is time. We need to build as fast as possible. So for this hospital, we built a massive structure in steel without not knowing what's going to happen inside. So each module that you can see between the columns can be moved, because it was just one part of wood, one part of glass, and one part of just a wall, depending on what's happening inside. So each window can give enough natural light to the spaces that are inside. Then Goethe, this guy, said like at some point that architecture is nothing more than frozen music. So then the question is like, what if we try to really synthesize and really materialize what Goethe at some point said? So this guy, Miles Davis, at some point recorded this album that is kind of blue, and he plays one song that is called So What? That sounds like that. So if Goethe says that thing, this is the score of Miles Davis. So then what if we try to draw on top of the score a line and then see what happens by just placing one in front of the other? So what we are really doing is trying to, every single piece of that is one part of that score that can actually be that. And then just by placing that, we were not thinking what we're gonna do. We were not thinking that possible that can become a bench in the public space. So basically what we're looking at is the materialization of a score, the materialize of the music. And this was, we were able to do this with digital fabrication. A CNC router machine will cut all the pieces millimetrically, and with the same CNC we were able to create some topographies of land for very diverse projects. This is a topography of that place, Puerto Vallarta, two beautiful mountains. We were able also to work with artists. So one artist, Davis Birks, he will draw with a pencil from the center, just without raising the pencil until the end of the spiral, and then we will digitalize that and CNC with the same tool. We will work with joineries inspired in interlocking Japanese methods with no glue at all, bending plywood, studies of facades and how the shapes and how the shades and the shadows can project on that facade, a scale model of a chair, the chair itself, and this one of the first prizes in terms of the best design of chairs in Mexico. And then another question arises. What if we're able to extract the mathematical formula of how the mushrooms grow? So we're not going to get into details of how mushroom really grows, but they really need biomass and light and many other elements, and we can extract that mathematical formula, which basically it's called an Euler's number. The Euler's number, it's about 2.71, something like that. It's famous in calculus, growth, and exponential growth. So extracting that mathematical formula and put it into 3D modeling software and then see what happens. So this is the natural growth of the mushrooms translated to an installation that the idea was to create some pockets where we were able to grow mushrooms. So the mushrooms, as I was saying, they need moisture, they need light. So we work with this Arduino plate that extract the information from the root of the mushrooms, and it's connected to Wi-Fi. So this was back in 2012. So once it's connected to Wi-Fi, then the question was like, what if we add and what if we give each of the pockets and each of the mushrooms a Twitter account, so then we can ask the mushroom, how does it feel? So by coding and having this connection with the mushrooms, the mushroom could reply, lindo dia in Spanish is good morning, have a nice day. The level of humidity, 78%, and the level of light, 82%. So by tweeting, we will get in communication with this synthetic nature. So once we had the connection with the pockets, we were able also to play with the LED lights on the installation. Everything was done with a KUKA robot. So the KUKA robot will be able to move in several axes, cut pieces, handle materials, and basically help us to work on that project. So it's all about technology, but also, what if we can represent the concept of balance? So Hello Wood is an architectural company in Hungary. They launched a contest that the idea was to represent balance. So balance is one of those words that carries both mathematical precision and poetic depth. It depends on where you stand, but here balance, it's about forces, it's about quantities, it's about gravity. So we build a strong and heavy self-supported structure made out of 4x4 pieces of wood, and it frames the cornfields in Csörömpuszta in Hungary, and then it's a very lightweight lattice, so it was like this lattice around with a very heavy structure in the center that invites you to sit there and feel the shelter of a tree. And at the office we were getting very busy, super busy, like doing many projects, and that allowed us to build our new office space. So I was very interested in using the entire facade as the main structure of the building, and by rotating these columns that are the structural elements of the facade towards north, so we can have enough natural light. And we were playing with Lego, we were doing a lot of sketches. So the important part here, it was like I was playing as an engineer and as an architect at the same time. And I designed this steel plate that is connected and is embedded in the columns of the concrete. So before pouring the concrete, so we can work very fast and we can create this double height where each team member has its own space defined by the facade. So it was cross ventilation, very nice place to be, and we decided also to have pizza and beer in the floor level. So it was like the best part of the project, because we were working in the second and the third level, and then just going down after work and enjoy a beer and enjoy a pizza. So the building became our business card, and we started growing exponentially. So we were asked to do something similar for an apartments building, another one with more units, even more with commercial spaces. And clients will go, please add a rooftop bar, a rooftop pool, a rooftop bar, and they don't care about trimming and cutting down trees, and they just want to maximize the square meters to sell, so they just don't care. And at some point it was overwhelming. I was very terrified about the footprint and the ecological impact that we were part of, because we know that the construction sector produces a lot of greenhouse emission. We know that we produce CO2 every single time that we turn a light, that we produce electricity. So the problem with producing too much CO2 is that it gets trapped in the environment, and then it leads to issues like stronger storms, like hotter summers, melting ice caps, and many other problems. So I was thinking there should be a natural way or a natural material that we can build with. So I stumbled upon Green School in Bali, and I went there in 2012, and I was impressed about the beauty, and I was very inspired about crossing this bridge, and I was sharing this story with Professor yesterday, that once you cross that bridge made out of bamboo, something happens in your mind, something happens in your heart, and something happens when you deal with projects. So years after, Bamboo Yurt was born, and I attended one of the first courses in 2017. Some of these guys are still part of Bamboo Yurt. And then I went back to Mexico, and that really empowers me to go to Mexico and actually work with bamboo. But the things that I was learning in Bamboo Yurt were very different, because the material that we have in Mexico is completely different. So we were using splits of guagua, and those splits we were bundling together as ribs, arches, bridge shells to make luxury spaces. And these luxury spaces, by doing that, brought me to the most challenging project in my life until now. The Four Seasons wanted to build a new hotel in Mexico made out of bamboo. They wanted something contemporary, they wanted something natural and very elegant, using cutting-edge technology to be able to achieve these shapes, super high quality standards, and attention to detail. The project is immersed in the jungle, and they have a unique style, and this is the reception building. It's an arrival pavilion that you actually arrive from here, the car, they take your car from there, and then you walk through this tunnel that is all made out of bamboo. This roof is made out of copper, and then you get into the project and into the villas. They just have 60 villas, so it's a very exclusive project. And everything is made out of bamboo and copper, crafted simply by bamboo splits. And I was very confident to build the entire structure with bamboo splits. You can see like all the grid shell is supporting the entire roof, and that just a simple grid shell of 10 by 10 centimeters could draw beautiful shadow patterns, and actually that project can be an award-winning project. So once I finished that project, I had a project blues, like not knowing like what was next. It was like very difficult to overcome like a massive project. And Bamboo Yurt was looking for someone to run the in-person courses. So I sent my portfolio and resume. I had some video calls with the directors, with the founder, Orin and Maria, and that's how I got there. Running Bamboo Yurt with an incredible team, meeting amazing people, and working in mind-blowing bamboo constructions as a dream job. So that gives me the opportunity also to share what we have been learning and suddenly come here and also share this knowledge with you and share the experience with you. So I'm really grateful to be here, and actually really thankful for all of you being here, because also you're part of this new chapter. So there is a kind of lightness that does not mean fragility. It's that lightness that if you grab a leaf that bends, but it doesn't break. That lightness that a structure can stand not by opposing gravity, but by understanding it. So I want to talk about some structural systems in bamboo construction. But because once I was asked to prepare this talk on structural systems that I never prepared before, then I was thinking how I can start adding more elements to this talk and not just being very technical. So I want to talk about that anatomy of lightness in compare, and how we use that with different structural systems. So I will talk about a high bar, I will talk about a tower and a grid shell as structural systems that we use as not only as a typology of projects, but also as a way of thinking. So we're going to explore these structural systems that give form to the lightness. And now, just to recap, we know that bamboo sequesters 50 tons of CO2 per hectare per year. One incredible reason to keep using bamboo. Just a single clump can hold 5,000 liters of water for 6 to 9 months. We were talking this morning that has an excellent weight to strength ratio. In other words, it's very lightweight yet strong. Its branches, once it's growing, the leaves can control the sun exposure and the rain dispersion. And a beautiful thing is that bamboo empowers communities and creates a sustainable income for the families. So 5 reasons just to keep it in mind that we can create a better world with bamboo. So when we speak about structure, we usually think in terms of stability, of holding and standing, being strong, etc. But when we speak about bamboo, we enter in another kind of logic. One that is not about resisting nature, but is rather growing with it. So the first structural system that I want to talk about is a hyperbolic parabola. In short, just hyper. Let's call it hyper because it's a long name. It covers an umbrella of different systems, which basically it uses straight members to create surface with double curvature. What do I mean with double curvature is that if you see like this kind of shape, it's folding in one direction and the other one is folding in the other direction. If you have Pringles chips that they come in just a can, they have that same shape. If you ride a horse, that's the same shape that a hyper has. So it presents this kind of marriage between concave and convex surfaces. So the result of that is a structure where 2 straight lines intersect at every point. You can see every single tie rope there, creating this captivating visual effect. So the curvature of the surface gives this shell extraordinary stiffness and allowing them to bear considerable loads and very long spans. So how does it work? The building process typically begins by first laying poles in one direction. It doesn't matter the distance between them, it's just eyeballing, and then you place another layer of bamboo poles on top. Once you have the second layer, you temporarily secure using rubber bands in each intersection, and the magic happens when two opposing points, you just hoist them or lift them using ropes or tripods, while the other points simultaneously you press them together, and then you can have like these shapes. Just one high part, and then you mirror another piece. For example, here, this is one module, this is another module, 3 modules, one here, another one here, and it looks like that. So just by mirroring or reflecting those pieces, that's how it can work in a very easy way. So for those of you that are in architecture and in 3D modeling, we use certain parameters as the amount of bamboo poles, for example, poles in each direction, poles in the other direction, the distance between them, and then we can play with all those parameters to create a structure. You can play with all those parameters to sort of find the structure. You can lift some points in a way to find a shape that you like. Now that we understand the high part, the most prominent used hyperbolic system in bamboo construction is the hyperbolic reciprocal tower. We're just going to call it tower. So the tower's unique characteristic lies in the marriage of the reciprocal structure systems that we were talking earlier with the efficiency of hyperbolic shape. So the intersection points generated by opposing twist. If we see how first every single pole is rotated in one direction, and then the other one is just mirrored, and we have every single intersection that provides with a lot of strength. What we're placing here, it's called a compression ring. Compression ring the same way that we're doing on site right now. So a compression ring holds the structure together by resisting inward forces. So all the forces that are going inwards are supported by that compression ring. At the same time, it adds triangulation. We were looking at the yurt, something like that. One ring here that it creates a triangle here, when in other parts it's just a diamond. So the possibilities of using a tower are endless, because in this case, Dapurnaga, this building, is using a hyperbolic tower system, which is very narrow in the bottom, very narrow in the top part here, and it widens in the base. So that means that you can play with those kind of parameters, you can play with those kind of information to achieve one shape. What we can work here in this parametric software is to play with the base radius of that system, with the top radius of the tower, with the height, and if we are connecting all of them together, then we can achieve many different options of how we can create a tower. We can increase the amount of poles, we can play with all the structure, and we can create different iterations of that. We are building a yurt with all of you, and it looks something similar like that. Oops. So the idea of that yurt is actually working as a reciprocal tower in a different way. And that reciprocal tower is two different shapes. So one tower is here and the other tower is here. And because it's reciprocal, you can actually collapse it and open it. And the tower, once you want to lock it in place, then you add a triangulation, and that's done. So what we're actually doing now, here on site, we already create the compression ring that will have a tower. So the difference with the first towers that I was showing is the diameter, and it's also the height and the amount of poles that we have. And the other structural system that we have is the grid shell. In bamboo construction, continually we innovate through structures like just spatial grid shells. So these grid shells are very lightweight, yet very sturdy, and it's fashioned just by from a lattice of bamboo splits. We were working also on creating some bamboo splits that they are elements that they are very weak. So every single piece is intertwined in an organic way. For example, this grid shell on top, you can see the pattern that is very random, but the pattern down here, it's just a very rational and very strong. So both types of grid shell, they work. Another grid shell is, for example, in the arc in Bali, that works in the same way. It's a lattice on top of two arches that creates this captivating shape. So the beauty of bamboo when working on grid shells is that we can build grid shells using both round poles in a big scale, but also split members and then adding many different layers to create whatever you want. It can be created just by placing a center point. That center point will give us a circle and a radius that we will work as a base diameter, as a base ring, and then it's just playing around. You can just add some splits, start placing them until you find a nice shape of that, weave them, tie them, and then the more splits that you add, the geometry and the pattern and the way that you can wave it is what it will give the strength. Think it in a way as a basket, or as like a bamboo basket. The more splits that you add, you can actually carry a lot of load. So the shell gains rigidity through its curvature, and suddenly the magic happens. It can hold a lot of weight and is capable to bear a lot of loads. So this grid shell reminds us that lightness is not weakness. Lightness, it can create stiffness, and a very humble material as a bamboo split that you can break it very easy. Once it's working together, then it can work and it can be very, very strong. So the same way, using parametric softwares, you can create and you can play with the base of the radius, with the patterns, make it organic, make it very organic or rational, so you name it. That's the way of form finding. So those three different elements, high arc, tower, and grid shell, are the essence of many, many buildings. So how does it work in practice? Let's look at how we can create using different structural systems in just one project. So this playground that we built in the Kukul farm, it's we basically launched a contest, and we received more than 80 proposals from all over the world, and we built the winner. The winner is inspired in the nudie branch shape, for those of you that dive, and you can find like this little animal as a nudie branch, and we built it during Bamboo Yurt courses. So we were adding some decisions on site, like adding skylights, letting the trees be part of the building. So once we received the concept design, the idea was to turning everything into parameters that we could manipulate. So imagine that you can play with the tower, you can play with the height, with the amount of poles, you name it, you can just, it's just making the process very fun. So that's one element. The surface is another element, play with the dimensions, the heights, the amount of leaves that the nudie branch has. Then play with the grid shell, the distance between the members, the density of them, the thickness of them. And very interesting that once you have all this information in terms of the grid shell, you can extract enough data as the length of the pieces. You can get a bill of quantities because you can have like all the information from that. And once you're playing with it and playing with all the parameters, see how this intersection point, X, Y, it's moving, and all the distances and the lengths, this is like to all the splits that we are gonna use in the entire surface. Once you're playing with them, they can change and they can give you enough information instead of going back and do it from scratch, which will take a lot of time. So we were talking about like those elements in separate, put them all together and play with them. You can play with the tower, you can play with the placement of the foundations, with the length and see how the arches are also reacting to the way that we're playing with the surface. So in Grasshopper, there's also another plugin that is called Kangaroo. Kangaroo is a physics engine that interacts, it's like a simulation of how forces and structural optimization will work, and will give you a dynamic simulation, will give you like several iterations of how the shape will behave. It will give you in real time an analysis in terms of structure, how it is stressed, how it works, so then you might want to add more splits or more support on that. So in Grasshopper, you can add and you can apply every single possible mathematical formula that you can imagine in Grasshopper. So you can talk about the Euler's number to grow mushrooms, you can add the Fibonacci sequence, you can add fractals, golden ratio, topologies. Every single element and every single mathematical formula can be applied into Grasshopper and can be applied to that form finding. And one concept very interesting is singularity. When we are playing with a grid shell, sometimes we want to change some shapes. And a singularity in geometry is a point in a pattern or a surface or a structure where the usual or regular rules break down. For example, if we have a grid shell that is just a structure made out of diamonds, and I'm gonna hide some elements, you see everything is a diamond, everything is a square. But if I start like taking out all the elements, suddenly I see a pentagon. It's a different shape, it's a different rule of what we were talking about earlier. That's a singularity. That singularity will give a different shape of the structure in terms of being, instead of being like just a natural shape made out of diamonds. There's a diamond here, 4 lines, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Everything is 4, but this one. This is the magic of working with those parameters, adding a singularity, breaking down that pattern. So that's how you can always place with different structure, with different parameters, because to design structural systems in bamboo, it's to translate the logic of growth into a structure. It's to understand that maybe stiffness is not always the answer, but that flexibility can also be a form of strength. So I would like to invite you to see a building not only as an object, but as a living system. A system that breathes, a system that is moving, a system that actually ages with grace. So I invite you to look beyond all diagrams and see them more like a poem of balance. So each joint is a verse, each beam as a sentence, and in every single structure, just a reminder of that living intelligence of nature. Thank you very much. Any questions?
Yeah.
代替大家呢，感谢路易斯刚刚的演讲啊。那个你们大家有什么疑问的话，那这机会呢都可以提出来啊。那刚刚我们也帮路易斯做一点补充，就是刚刚有出现一些比较专业的部分啊。那个我们在做一些建筑设计，现在都会用 所谓的参数设计、参数建模。以往的那个叫做3D 建模，就是做一个一个一个，那如果要改，就是慢慢就回头去改，像做积木、做粘土一样啊。那我们现在新的观念是用参数，就是把那个建模的逻辑，像是写程式一样，把它建构起来。然后里面有牵涉到一些量的调整，随时可以调整那个量。刚刚有出现一些画面了啊，那大家不一定会懂，但是现在的科技了啊。大家有没有什么疑问啊？你们尽量的用英文发问，如果不行，我帮大家翻译。来吧。
Thank you for your speech, and I want to ask if we use the computer to predict how the bamboos and the flexibility that the bamboo is a natural product, and how do we know if each one fits into our model?
So how to use the natural information to apply that information into softwares, right? So nowadays it's very difficult. We're still working on that and doing and creating experiments. So the nice thing about the projects that we do in Bamboo Yurt is that it's all about experimentation. So we calculate a little bit, we do a lot of scale models, and then we build one-to-one scale structures and see what happens. And some cases we will need to reinforce the structure. In some cases it will not work. In some cases it will considerable be better than we expected. So the easiest way to do now is to use some, for example, if you're using SAP 2000, SAP 2000 is for structural calculation, then you will use steel parameters. And then those parameters you need to extract and do a lot of testings of how much the bamboo can support, can hold, and then sort of like over text and translate the parameters that you have in steel to the bamboo. So in the beginning we were thinking that because there's like around 1,600 species of bamboo, every single bamboo is different, meaning that every single piece will behave different. So we need to create a lot of testings. So now we're working, and we did a collaboration with Base Baha'i in the Philippines. They have a lab that they are testing a lot of different pieces, so we can extract that information and then apply it to some models. Because with Kangaroo or with Ladybug or with SAP 2000 and many other softwares that are out there now, we can estimate and simulate some things, but we haven't get to the precise thing. And we have several examples that we have been doing. So now you can use like some parts of steel and then just apply that. And the best way to do now is just by experimenting one-to-one as our laboratory that we have in Bali, is just like playing with it and doing things.
I can share some of my experiences as well in response to that question. It's really difficult to make a really precise analysis in terms of like bamboo when construction, especially when you want to bend it.
Yes.
It's really difficult. You can bend the bamboo, but to predict that curve, you can curve like that or like that. To make a precise prediction is really difficult. And like we're doing some research projects, and we are working with like civil engineering department. They have software that we don't have, like finite analysis software. 中文叫做有限元素分析and they can like calculate like the frictions like between like materials, which is something we cannot do.
Yeah.
But still, even use that software, it is still difficult to make a precise prediction. We need to make some experiments like physical experiment, like we on site, we use a few bamboo poles and bend them and add some weight under the structure and see how much it deforms.
Yeah.
To be able to extract the parameters that we need and put that into fitness
Yeah.
analysis software. 就是我们是像我们在这边跟交大的土木系老师合作，我们在做一些研究。就是刚刚那个问题是如何精准的去预估评估那个竹子，特别要弯曲的时候很困难。但是他们比如说用有线元素分析，那个是一个专门的软体。即便是这样还不够精准，我们打算要用一个竹子先做一个测试，去给它力，看它变形多少。把那个数据再输到软体里面去，会比较精准，也没有完全精准了。因为最后你会用那个竹子跟测试竹子又可能不完全一样，所以是太难了就是尽量逼近，但是还没有办法说一定完全精准。
So to give you an example, this is a result that the computer gives you on how the surface needs to be. So this curve here, it's how the software tells you that that's the way that it needs to work. But when you grab a bamboo split and try to bend it in this direction and then going in that direction and just in this part trying to really bend to this shape, impossible. So then it's kind of like a balance between what you can learn from the bamboo and what does the information and the software gives you. Because this shape, it will be very difficult. But this one, it works better with bamboo. This one, it works better. This one is also almost straight. So that's how you can, the software can tell you something, and then once you apply that to the reality, then the split will break. And it doesn't mean that the bamboo is not strong enough. It just, that particular split, break.
I think many of us just want to build our own little structure, and maybe we don't have the background of architecture or using the program, something like that. And how can we do a bamboo structure by ourselves and without so much calculation, and maybe have something like do it and fix it and do the structure by hands, not by computer. Is it possible?
I have the best answer. Come to Bali. I mean that's a very, and I'm being honest. Come to Bali. In our courses we teach like during 11 days, like from harvesting to clump management, to model making, to joinery, to construction, design, and many other activities. So whether you would like to learn a little bit more about design, learning a little bit about how to process the material, etc. So that's how you can start. The other way is that in Bamboo Yurt we really want to share the knowledge, and if you're not able to go to Bali, we also have a lot of live trainings online for free. We have online courses, we have a lot of resources like out there. We have a blog that you can just go there and type what you want to learn about and find the answers there. So we are launching now in the before the year ends, we're launching a structural engineering for bamboo course. It's online and it's going to be for free. So we found that the bottleneck of bamboo construction is actually the structural engineer. So we partner with Base Baha'i and we get funds from the Hilti Foundation to do a new course that we invest more than 1 year of time like creating it to deliver like a very good content and very good information. That's on structure, but also we have a new one that we're gonna launch in the 21st of November of digital design. It's all about using rhinoceros, grasshopper, bee-ray, and all those different elements. So just dive into what we can offer in Bamboo Yurt. We have a lot of free resources. You can actually just send us a message or an email, ask for a consultation, and we're always happy to support.
So please. I think some of the people still don't know what is Bamboo Yurt, even you talk about the ideas. Could you say more about, for example, the financial support of Bamboo Yurt, and also how it started? I know it was a couple, and how this kind of Bamboo Yurt started. Yeah.
Okay, so I'm gonna tell the story very fast because it's a long story of Bamboo Yurt. Bamboo Yurt is the educational arm of many other companies that are part of a big ecosystem of bamboo in Bali. This ecosystem started with Green School. Green School is a school made out of bamboo, and when John Hardy decided to do the school, he decided to do the entire school in bamboo. Once he had a school, then he needed a factory to process the material to create and to start working in the construction. So that's how Bamboo Yurt, another company, the professional construction site, started. We have a factory. There's that factory that we process all the material, we treat the material there, and then the construction company needed as well an architectural firm that was able to create the designs and the concepts and all of that. So that's how Ibuku was created. Ibuku is the architectural firm, the conceptual thing. They do the creative process and the drawings and the concepts and the nice ideas. And then people started asking, how do you do that? How you are able to build with bamboo? So that's how Bamboo Yurt started, as an educational arm to share the knowledge of how the professional companies as Bamboo Yurt and Ibuku creates design, and that's how we can share. So Bamboo Yurt, it's a sister company of Ibuku, a sister company of Bamboo Yurt, of Bamboo Inda, which is a hotel, that it's all about bamboo, it's the same ecosystem. So when you go to Bamboo Yurt and if you attend one course, you have the opportunity to visit Ibuku, to visit the factory, to visit Green School as part of the program. And that's what we do. So basically we create a lot of projects. Some of them are like the experimental part before we go to a professional site for clients or for like real projects. So some of the projects and the different ideas of Bamboo Yurt is just testing, it's just experiments.
Hey, and do you want to talk about your online courses? Perhaps they couldn't go, but they can attend the online courses.
Yeah, the online courses, as I was saying, like these two new courses, structural engineer and also digital design, we're gonna launch them. But also we have small courses, for example, harvesting and propagation. So for those of you that are more interested in that process, we have like one small course out there that is all about harvesting, propagation, how to properly harvest the bamboo. We have another online course that is all about treatment and preservation, because bamboo needs to be preserved and needs to be treated. Otherwise, in just about 2 or 3 months, it will get eaten by wooden-bored insects or termites or many other insects. So we have another course on that, and we have also another course that is like the basis of how to understand and how to design with bamboo. The course is called The Principles of Design with Bamboo. So that's like a very nice first stage if you want to start your journey in bamboo construction and bamboo design.
Yeah, wonderful. Also, we as Taiwan Bamboo Society, we also have something to share with you. We have published a book, pretty much like a handbook on bamboo construction, and it's called From Bamboo to Bamboo Houses. 从竹子到竹房子啊。We even have a digital version which you can download online. 从竹子到竹房子线上专业版啊，大家都欢迎看，已经是台湾的学习的教科书，如果你们还没有看，都可以看。And if it is not enough for you, you do need to go to Bali.
Let's organize a group with you, and then we have like just people from here and having a nice group. Because we also do that. Like sometimes we receive like custom courses. We did that with the Taiwan Bamboo Society, and it was great. It was a great experience, and it's just a matter of putting together a group. We can create a customized course on whatever you want to focus, because there's a lot of things that needs to be shared, and depending on the amount of days, depending on the amount of people, we can curate a very interesting course.
Thank you for your sharing, Luis. I'd like to bring a very new big question about the construction on slope. If we have a bamboo forest, but which is built in a very steep slope, and want to build a platform, how we should do to start to make the surface more constructible or more easily to use all the material to bring to the hills.
Okay, so the question is if you have like a hill and you want to build there,
Yeah.
and then you want to create a platform.
Yeah.
So if I can just do a quick drawing here. You have a hill with trees, and then you want to build something, and then you want to create a platform.
Yeah.
So first thing, you will need to take out all this piece of land and do a lot of damage. Take out this tree that was there, and then grab this triangle of soil and put it here. Yeah? That way you have all this platform. The problem with that, if you calculate all this amount of soil and then bring the soil here, first of all, the cost of that is super high. The second cost is the ecological impact of that. So better don't do it. Better think about it in a different way. What you can think about is, instead of doing this platform because you want something flat, you have a piece of land, you have your beautiful trees, and then what if you just dig here as part of a foundation? You can do a retaining wall or whatever you need. And then you have like a very nice house with a very nice view. You're not damaging the soil, you're not damaging the platform. You're actually like just taking out a little bit of the soil there to put the foundation, a little bit of the soil here. It's cheaper. You're not moving any amount of soil, and you can do with your partner. So better do it this way.
Yes, thank you. But what element or factors should we take account into build different foundation at different levels, or how to make it more solid?
How to make it more solid?
Yeah.
I mean, it depends on the project. So first thing is that it sounds like a little bit complicated, so you might want to ask like a structural engineer to help on the process. It's not that there's a rule of thumb that you then say like, okay, so every single foundation you will do 1 meter and 20 centimeters deep. The foundations are going to be 60 centimeters by 60. There's not that thing. we can calculate something, you can like have an idea of that, but we don't know, as for now, like with the question, we don't know how much weight is the project, what kind of roof, if that roof is gonna be very heavy, if there's wind that will pull out this roof, or if there's a lot of weight here, how the soil behaves. If this soil is rock, then the foundation is smaller. If this soil is lime, the foundation needs to be bigger. So it really depends on the project, and it might need a better calculation. But at the same time, like you will need to do a very big retaining wall here and another retaining wall here that will require as well structural engineers. So yeah, like the short answer would be like once you have the project, square meters, how it's gonna be, what type of roof elements, where it's gonna be built, and all of that, then the structural engineer can give you a precise solution with enough drawings and enough materials for you to build it.
难得机会啊，把握，可以来难度高一点的问题，我回答不了就交给路易斯啊，对吗？看在场的这些建筑家都问个难一点的。好了，不勉强，还没有。
Louis, do we ever try to build a bamboo house more than 2 floors, 3 floors, maybe 5 floors?
马里岛到3
6 floors.
You passed.
That was built many years ago by Bamboo Yurt, and it's 6 floors. It has a reciprocal tower in the center. A reciprocal shape is the tunnel. This house is called Sharma Springs. Still there, still alive. After earthquakes, after heavy rains, etc. This is in Bali, in Green Village, and it's 6 floors.
How long do you think this? How long do you think this building will last?
So it's like a very complex question to answer, because some bamboo buildings can last 3 months, some bamboo buildings can last 5 months, but some others can last more than 50 years. Why some bamboo construction can last 50 years? First, because the bamboo is well treated against termites and against wood-boring insects. So that's a first thing. Then the second thing is that the project needs to be well designed. And I'm talking about well designed not in terms of how beautiful it looks, but in terms of how it can protect against rain and against the sun. So every single structure that we do, they have overhangs. The columns are recessed to the center, so they can be protected from the sun. The foundation is higher, so then you protect from water. So once you do preservation by design, meaning that if you design properly with overhangs, so I remember a very good carpenter in Colombia. He was saying that the best bamboo construction is the one that has a big hat to protect from the rain. It has boots, so you can avoid the rain. It has a jacket, so it's coating and it's well maintained. It has gloves, so thinking it that way. So at least good hat and good boots that will make the building last longer, plus all the treatment.
I would like to ask if if there is damage on of the bamboos, is it possible to interchange with another bamboo? Is it easy or is it very difficult? And how do you repair some of the bamboo structures?
Okay, let me show you a picture to explain that. And in this case, we're talking about a principle of in structures that is called, I didn't explain that in this talk, but this principle is called reciprocity. Reciprocity means that redundancy, it's another concept. Redundancy on structure, it means that it's redundant, that we have a lot of elements working together. This hyperbolic tower, this element, it's connected to the ring, is connected to another bamboo pole, is connected to another bamboo pole, and so on until it goes down. So the redundancy of elements and the redundancy of intersection and interconnection is so high that if this bamboo pole is broken, if this bamboo pole is rotten, it cracks, the entire structure will behave the same. It will not happen anything because of its redundancy. So if this bamboo pole, you actually need to replace it, you can just take it out, take out the screws here, take the bamboo pole, cut it, and even if you shake the structure, it will behave and it will remain in the same way because of its redundancy. And we like to do some exercises with the participants that when we create a tower, for example, this tower. This tower is not connected to the ground. The bamboo poles are just sitting in the ground. These are just hand tied. They are not screwed. They are not having threaded rod or nothing. And I always like to take out the scaffolding, put 3 people on top, and go there and shake the structure. And it moves. Of course, it moves. It's flexible. It's light. It's flexible. But it doesn't matter. The structure remains there. And even having people on top, I like to untie some elements and take out one bamboo pole, or at least untie it, and the structure remains stable because of its redundancy. So if you need to replace some elements, the best, like on a bamboo construction, it's the easiest way. You don't need to add a lot of scaffolding, etc. Imagine that we need to replace this massive column in the center of this building. It's kind of impossible. If that column breaks, or if that column has a failure, the entire structure will feel that. With bamboo, it doesn't happen. Redundancy, that's the concept.
Hello, thank you. I live in a concrete house and it's old and I don't have money to tear it down and build a new one. So I'm thinking about building a bamboo roof on my rooftop. What do you think of this idea of using a hyperbolic rooftop over my concrete apartment? Maybe
That's super easy. That's super fast. It's very low cost, and just with 2 people you can build it. How big is that? How big is the construction?
it's a three level apartment.
Oh, three levels.
Yeah, it's like 3 stories and it's about 50 years.
Okay.
And
But how big is if you
like these guys from
Oh, this it's
But-
massive.
like half.
Half of this. So if you have any architect that can tell how big is this space, like from this column to the other one?
Like 8 meters. 8 meters times
8 meters?
times.
But
Maybe like 5, right?
Like,
25.
5 by 5.
right? And
5 by 5, you have 5 meters here, 5 meters here, 5 meters here. So then this is 10 meters.
Maybe.
I divided this in half because the easiest way to do a high part is starting from a square. You have a square here, 5 times 5. If you have this 5 times 5, I would like you to divide this one into 8 or 10 pieces. I don't know how many I'm doing here, but at least you will need to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 bamboo poles of 6 meters long, because you have 5 meters here. So this is the amount of bamboo poles that you need, just for one module. Then you have 2 modules here, so then this 20 times 2, you need 40 poles. And then we were talking about how to do the high bar, right? You place these elements, and then you take this vertex here and this one, and you just lift it. Having the same shape, then you do another one in the opposite. If you look at that in a front view, it will look like something like that, like to this particular line is this one. And then you can drain the water to this part, you can drain the water here, you can drain the water here. So as long as you have some supports, that I guess that you already have some columns or some walls, then you can have your nice space here and use the real house that you have.
Okay, thank you. And if y is like 5 meters, and how high would be the structure?
How high? Let's say that at least this part, at least you want to have like 2.4. Why I'm saying 2.4? Because it's like a standard measurement, just for a space like that. But no less than this. No less than 2.4, 2.2 meters and 40 centimeters. Maybe you can do 3 meters. And I'm pointing to the lowest part. Once you raise this point, which is this one, and you lift this might go to maybe 5 meters. Kind of.
Another question is, because it's high, so I don't know if the typhoon or winter winds, especially in Bamboo.
You can add some cables or tensors here, or this element, as long as it's very well connected to your wall, so the pulling forces will be supported and bear with the foundation, or with a cable, or with something that just hold it down. Imagine that if you're like under the rain with an umbrella, and there's a lot of wind from below, you want to take it down, right?
Yes.
So imagine in the same way. But the good thing about the high part is that once the wind blows here, because of the shape, you can take it out.
So where do I put the pendulum?
It depends on where you can tie it. Let's say that you have a tree here. You can pull one there. If you have a tree, I don't know. If you have something else, then you can just take this one down. It really depends on
the neighbor's building.
yeah.
They are all connected.
Yeah.
So maybe you just want to do and go down here.
Okay.
So in each intersection, you can have one pole going down. So that will like hold all the forces that are pulling.
Thank you. Thank you.
I want to see that house.
好，大家看看，还是
I would also like to know what materials you hold the bamboos to the ground usually. What kind of methods or materials do you use?
I don't know if you have.
还是在这边再推销一下我们台湾族会的书啊，有一些基本的问题可以先看一看啊。今天他比较难回答所有的这些事情，我觉得。
So every bamboo pole will land on top of a stone that will work as a moisture barrier, and then this part is concrete, and this concrete goes underground as part of the foundation. Now inside this concrete column there's one rebar, one steel bar. That steel bar goes from the foundation going up to the pillar of concrete, and then is tied to the bamboo. So the only way to tie, or the only way to anchor a bamboo pole to the foundation, it never go right to the ground. It always needs to be on like above, because of the bamboo as a live material, it will absorb water. So then the way to do that is just raise the foundation, the concrete pulls up water. So then you add a stone or something in between the bamboo, and the concrete to avoid that pulling of water. So it works as a moisture barrier.
Size of the rebar.
12 millimeters. 12 millimeters, that's half an inch. That's in the coding like number 8 or number 10. Only one. One bamboo, one rebar. There's one bundle of bamboo poles here landing, and it's attached to just one rebar. So if you have concrete column that has more than one bamboo pole, then if you have 4 bamboo poles growing from the foundation, then you have 4 rebars. If you have a foundation that from where it's growing 3 columns, 3 rebars. If it's just one rebar. How is it connected? The bamboo, you will put the bamboo inside the rebar. The bamboo is hollow. It has a cavity. Exactly. You just put the bamboo inside the rebar. If the direction of the bamboo is in this direction, you bend the rebar and you place that bamboo pole there.
Does that need to fill with cement?
With mortar.
Oh, mortar.
So it's a very liquid cement, so it can like be a joining material between the bamboo and the rebar. It's just a little bit. You just need to go high to the second knot of the bamboo and fill it with mortar. Once everything is secure, it's almost like one of the last processes.
The cement, the concrete could shrink afterward.
Yes.
So in Taiwan, we use a particular type of cement, which is shrinkless, which doesn't shrink.
What kind of cement?
I can find it one. I don't have the name in English. In Taiwan, we call that Wusou
Because in Thailand they have the same problem.
Yeah.
So that's a good point. Like the concrete behaves in a different way than bamboo. So if the temperature is high in levels of humidity, the bamboo will absorb that moist and it will expand. It will have a lot of density. Once the temperature drops and the humidity levels drop, then the bamboo gets dry. So it sort of like gets dry and it shrinks and it will try to compress and it will try to grab the concrete that is there and it will crack because the concrete behaves in a different way of the bamboo. So some techniques, for example, in Latin America, we have the same problem. So we just wrap around the bamboo with a stainless steel band, sort of like just to hold it in place. You can add like 1 or 2 or 3 different bands, and then the bamboo might crack, but it will not like explode. Yeah? It will not explode, but just to.
Two questions. One is how to make the joint and the material of the joint when you cross the bamboo. And how does it behave when the earthquakes come?
That takes a course.
Yes, that takes a course because joinery, it's a full thing. But the easiest way, if you have a cross, whenever you have that cross, you drill through and put a bamboo pin. And that's it. But yeah, it's a long question because what if instead of like just intersecting, one bamboo pole is holding another one and supporting another one? Then there's a fish mouth joinery. What if there's a bamboo pole that is connecting in an angle? Then we have an angle joint. Then what if like there's many of them? So, but the easiest way is just drill. It's just drilling. And it doesn't require like a lot of skills or carpentry skills, because the same with the high bar that you're gonna build for your roof, the same way of a simple joinery, you just need to drill straight and put a pin or put a threaded rod, just a metal rod and bolts, and that's it. We have been building one project in Bali that has no fish mouths, has no different and difficult joinery. Everything is just by intersecting and interlocking elements. So it's very simple. Whenever you have an intersection, drill through and bolt. Just that.
Sorry, I still have a maintenance problem I want to ask. I saw a picture that with the roof, and it's all the roof is made with bamboo. And because I knew that some Aboriginal people, they build their house with bamboo and even with some grass. They have to maintain like every year. They have to refresh their rooftop every year because it will get rotten.
Yeah.
Or shrink.
So for example, this project, it has bamboo shingles. So it's flattened bamboo. All of this is bamboo. This roof is also bamboo shingles, like just the top part. Most of them, this project, all of this is bamboo shingles. And because it's a natural material, it will get damaged. It will bleach out, so it will turn white. It will get moldy, it will crack. It's not structural, so it doesn't matter. So, because it's a natural material, yes, you will need to replace it. You will need to replace like in about 7 years or 10 years, depending how exposed to the sun and how exposed to the rain is. Some roofs, they will last longer, some they will last less, it depends. So yes, bamboo shingles, you need to replace it. Thatch roof, like with palm, you will need to replace that depending on the quality of the material. And some other projects, nowadays, if you have enough budget and you don't want to waste and you don't want to spend a lot of money on replacing this one, you can use copper, you can use brass, you can use zinc, you can use clay tiles as well. You can do asphalt shingles or asphalt liner or any other material.
柏油、沥青。可能太技术的问题了，我们可能今天没办法讨论的仔细。
No technical question. And following question from this, and how about putting natural paints on the top? No.
The bamboo has the top part, it has a skin. So if you touch the bamboo, it's kind of like plastic, right? It feels like nothing will stick. And that's true. If you add paint, if you add something, it will not stick, it will not work. So the good thing about it is that the silica, it's kind of like waterproofing in a like a very minor way, so it will drain the water. But if that coating or that material, it's in order to extend the longevity of the bamboo, we haven't get there yet.
And if you haven't done any bamboo construction, I would recommend you to start on something fundamental. You know, do some basic things. I don't think you want to, you know, when you go back and go straight to build up your bamboo roof.
Do scale models. Scale models works. Scale model helps a lot.
And yeah, once again, check out our book. 台湾族会做那个书，就是因为过去太多大家有这方面的问题，那个很基本的问题，先看看书吧，看看基本资料。我们分两个版本，一个网络书店买得到的那个实体版，那个是适合一般大众读的。线上专业版反而免费下载，说那个是给真正认真要做主建筑的人。 更专业的资料啊，大家都可以读读啊。
Thank you, Luis. Thank you for the speech. I'm curious about we got some climate damage and disaster now in these decades or maybe in the future. And just like we have a city in Taiwan called Hualien, it's in the east. And have very strong damage now. And I think after your speech, maybe bamboo or wooden cabin or maybe this kind of structure or we call it architecture, we can fix this problem very fast because wooden and bamboo is grow from nature. So how is there any experience that when Bamboo Yurt or when other countries have this experience to teach people when the damage comes, when the climate problem comes, so they fix their home with wooden or maybe bamboo very fast, and they got to have 3 months or maybe 6 months to live in this nomad place, not for the long one, and they can nomad or they can build this place to another place very soon. So is this experience exist, or if we want to have this experience, is this possible? And what is the most difficult problem in this system?
So the great thing is that there are already examples out there in the world that works. So if we talk about natural disasters, let's think about three: earthquakes, typhoons, and
Yeah.
flooding.
Yeah.
Earthquakes. The bamboo house will sort of like move and dance, and it's flexible, but it will not crack and it will not fall. So once you're doing a bamboo house, you will feel how it shakes. But there are many houses. For example, there's one example, very important in Colombia. There was a massive earthquake. There are some houses made out of bamboo. They were all in place, standing next to many other concrete houses that all fell down. So bamboo has that ability to withstand earthquakes. Then typhoons. Typhoons, they can blow away one house. But if it's made out of bamboo, because of the way of designing, it has openings so the wind can go out. It has a very lightweight roof that even if the house is very damaged from a typhoon, so then the roof will come out, but the rest of the house will remain intact. Whereas if you have a normal construction with a typhoon, it will get hit by the typhoon and it will fail and it will be complete disaster. And flooding, all the houses and all the bamboo constructions that I was mentioning earlier are lifted from the ground. So even if there's a flood, even if you have 60 centimeters of flood or 80 centimeters of flood, if your construction and the bamboo construction itself it's raised from the ground, then it doesn't matter. You will have a nice pool for a little bit, and then the concrete, it doesn't matter if it's in touch with water. So then the bamboo house can be there. So those three natural disasters can be withstand with bamboo construction. And if the disaster already happened, then a bamboo construction can be done very, very fast. You can just arrive with some bamboo poles and do shelters. And there's a lot of projects nowadays that are doing research on projects for natural disasters and resilience and that kind of things. So yes, bamboo is a very good solution for that.